In this video, I want to have a look at errors in measurement. So when we say that, we're referring to the difference between the measured value and the actual value. So a measurement has an accuracy of plus or minus a half of the smallest unit that's marked on the measuring device. So if we have a look at these two examples, our first picture here is of a speedo, and you can see that it's got every 5 kilometers per hour marked. So that means because that 5 kilometers an hour is our smallest unit, the accuracy of that speedo is going to be plus or minus 2.5 kilometers per hour. If we have a look at these scales then, you can see it's got 65.7 kilograms written on it. So it's accurate to 1 decimal place, which means that it's going to have an accuracy of plus or minus 0.05 kilograms. It's plus or minus the smallest unit, which was 1 decimal place. So that level of accuracy is what we call the absolute error. We can use that absolute error to figure out what's called the percentage error. And that helps us tell how significant an error in measurement is. So let's have a look at an example. So our example says the amount of petrol that's pumped into a car is measured to be 35.8 litres. Then our question has 3 parts. The first one asks us what is the absolute error of this measurement. So that's what we were doing on the last slide. So because it's measured as 35.8 litres, it's measured to 1 decimal place. Our absolute error for part A would be plus or minus 0.05 litres. Part B then asks us to calculate the range of possible values of the measurement. So what the measurement actually could have been, but we've rounded it to 35.8. So the maximum it could have been would have been that 35.8, 35.8 plus that 0.05, which would have given us 35.85 litres. And the minimum that it could have been would have been that 35.8 minus the 0.05, which would have given us 35.75. So the amount of petrol we actually got could have been anywhere between that 35.75 and 35.85 litres, and we've rounded it to 35.8. Part C asks us to calculate the percentage error. So that's using that formula that we've got up the top, which is going to be our absolute error, so 0.05, divided by the measurement that we took, which was at 35.8. And we're going to turn that into a percentage by multiplying by 100. And we will end up with approximately, if we round to 2 decimal places, 0.14%. And that's to 2 dp. So a 0.14 percentage error isn't huge, so we should be okay with that, but it tells us how significant that error is.